Hi everyone! We are the Canadian Society for Epidemiology and Biostatistics at McMaster University. We are an interdisciplinary, student-run organization that aims to provide an avenue for undergraduate and graduate students to explore their interests in epidemiology and biostatistics. In our last video, we spoke about some key concepts of epidemiology, including p-values, using p-values to approach hypothesis testing, and the idea of confidence intervals. Building upon that, we will be discussing some important concepts regarding study designs and different methods of measurements, as outlined here. Epidemiology, as most of you might know by now, is the study of how disease is distributed in populations and the factors that influence or determine this distribution. In order to study this distribution, measures of occurrence and measures of association are utilized. Measures of occurrence include incidence, prevalence, hazard rate, cumulative incidence, and rates over time, whereas measures of association include relative measures, such as relative risk and risk ratios, and absolute measures, such as absolute risk and attributable risk. We will now be discussing different study designs and how these measures of association are used in them. First, let's talk about case-control studies. Case-control studies are observational epidemiologic studies with a comparison group. Subjects are grouped according to disease status. If the subject has a disease, they are considered as cases. Controls, on the other hand, are the participants who do not have the disease. These two groups are compared to find a common exposure that may have caused the disease. When selecting cases, incident cases, or people who have been newly diagnosed within a recent time period are much more preferable. This is because prevalent cases are likely to have the disease for a longer time. This might make it harder to assess the exposure prior to the disease. Furthermore, when selecting controls, they must be selected from the same population so that they are also exposed to a similar set of conditions as the cases. Information regarding the exposure of these subjects will be collected retrospectively, and the subjects can then be categorized according to the exposure status. As you can see in this diagram, cases who were exposed are categorized separately from those who were not exposed. The same principle is applied to the control group. This information can then be added to a 2x2 table to apply further statistical information. In this case, the cases and controls are categorized into exposed and non-exposed groups. For example, box A represents the cases who are exposed. Now that you know a little bit about case-control studies, let's talk about the odds ratio. The odds ratio is a measure of association that is used to understand the relationship between variables of a case-control study. The equation for it is given here. In order to calculate the odds ratio of the 2x2 table, you take the product of the cases who are exposed, that is group A, with the controls who are not exposed, that is group D, divided by the product of the cases who are not exposed, group B, and the controls who are exposed, that is group C. A real-life example of this is to consider a group of 300 students, out of which 50 reported a severe stress attack in the 24 hours following writing their epidemiology exam. Those 50 who were ill stayed behind. However, only 20 students who were not ill were contacted by the McMaster Health Sciences to act as controls. The 50 cases and 20 controls completed detailed questionnaires about their stress management practices. Through the data, 4 individuals who had done Tai Chi, which is the exposure in this example, had severe stress attacks. On the other hand, 46 people who had stress attacks did not do Tai Chi. The odds ratio here is interpreted as the odds of getting sick or stress if you did Tai Chi. The ratio turns out to be 0.015. Since the odds ratio is less than 0.1, there is a negative association with the exposure and the outcome. Therefore, the exposure is protective. Again, people who do Tai Chi are more protected against stress attacks. The second basic study design used to conduct epidemiological research is a cohort study. There are two types of cohort studies: prospective cohort studies and retrospective cohort studies. Both types are very similar in nature. In prospective cohort studies, the study subjects are divided into two groups based on their exposure status. This is the first difference between a prospective cohort study and a case control study. Case control subjects are grouped based on their outcome and not the exposure. Furthermore, in the prospective cohort, the subjects are then followed forward in time to see whether they develop the outcome. Subjects who develop the outcome are then considered as cases, and those who do not develop the outcome are considered as controls. Retrospective cohort studies are different than prospective cohort studies in that both the exposure and outcome have already occurred at the beginning of the study. Participants are recruited into the study, and then retrospective assessment of the exposure takes place. Participants are either classified as exposed or not exposed, and then followed forward in time to determine whether they could develop the outcome or not. To conduct a retrospective cohort study, researchers must rely on previously conducted data from sources such as medical or employment records. The key difference to note between the two types of cohort studies is that the outcomes have already occurred in retrospective cohort studies, and researchers must look back in time to assess both the exposure and the outcome. Whereas in prospective cohort studies, it is a requirement that no participants have had the outcome at the time of enrollment. We will now give a brief overview of an example of a prospective cohort study. This is an example which gives you a better idea of how the classification system works in such a study. On the diagram, E stands for the exposure and D stands for the disease. In this case, we have a group of people who are willing to participate in the study to see if doing Tai Chi could help you reduce stress during exam seasons. The subjects are divided based on whether they are doing Tai Chi or not. Then they are further divided into groups based on whether they developed a stress attack or not. Now that you have a better understanding of prospective cohort study design, let's talk about the types of measures of association used within the study design. Same as case control, we can divide the number of subjects based on their status into a 2x2 table. We are then able to find the risk of the outcome, the disease in this case, in the exposed group by simply dividing A by A plus C. We do the same for the risk of the disease in the unexposed group by dividing B by B plus D. Relative risk is then simply the risk in the exposed group over the risk in the unexposed group. To give you an actual example, we are going back to our Tai Chi study, and we are simply assigning a random amount of people to each group just for the sake of this example. We assume that 21 people did Tai Chi, and out of those 21, 4 developed a stress attack and 70 did not. We also assume that 49 people did not do Tai Chi, and out of those 49, 46 developed a stress attack and 3 did not. You would then find the risk of stress attack in the group who did Tai Chi by dividing 4 by 4 plus 17, which gives us 0.19. You would do the same for the risk of stress attack in the group that did not do Tai Chi by dividing 46 by 46 plus 3, which is 0.94. Relative risk is then simply 0.19 divided by 0.94, which would give us the value of 0.20. You might ask, how would you interpret this value? Well, the answer to that question would be if you do Tai Chi, your risk of having a stress attack is 0.2 times of someone who did not do Tai Chi. Also, relative risk is less than 1 which tells us that Tai Chi is a protective factor against a stress attack. Thank you for watching this video on epidemiological research study designs. If you have any questions, please send us an email at mcmastercseb@gmail.com and stay tuned for further videos.